Welcome back. Now we're going to look at writing domain in interval notation. Let's take a look at f of x is equal to the square root of x. So in the last video, we talked about that the domain of this function are all numbers that are greater than or equal to 0. So interval notation looks like this. We want things that are greater than or equal to 0. So actually I want to start with this bracket, and I'll explain why in a moment. And that means I'm going to start at 0, it could be equal to 0, and I can go all the way up to any number that's greater than 0 forever, so infinity. So that's what interval notation looks like. If this is a review for you, then you might be able to go through this video kind of quickly. If not, then you might need to watch this a couple times or pause every now and then. So if this is new for you, I usually start to think, until I get used to writing in interval notation, I think about a number line. And I'm just going to put 0 here at the center, and 5, 10, okay, -5, -10. And I want to think about this statement, all numbers that are greater than or equal to 0. So that certainly means that 0 is valid and 5 is valid, and here in the middle at 2.5, any of these numbers, all of these numbers are valid. So because it could be equal to 0, I'm going to use a bracket. Okay, so special notation, we need specifically a bracket, and then I would shade all the way to the right because all of these things are valid. So this bracket is that we put on the number line is how we start that interval notation. This literally reads, start at 0, it can be equal to 0, that's what that bracket means, and then comma. So we separate this interval. This is where we start the interval, and this is where we end. Well, we never really want to end. All numbers that are greater than 0 are valid. So this goes up to infinity. So we say up to infinity, and we put a parentheses. Infinity will always have parentheses. Bracket means like kind of a hard stop. Well, infinity never really stops. So you can kind of always just go a little bit more and a little bit closer. In the next example, g of x equal to 1 over x plus 1, we found that the domain were all real numbers except -1. So again, let's start with a number line. Here's 0 in the middle, -1, +1. Okay, just going to make a simple number line. And everything was valid except -1. So 0 all the way up this way, so this was all valid. -0.9, -0.999, all of these numbers here are valid. When I evaluate g of x at -0.9, I don't get 0 in the denominator. I get +1/10. I can divide 1 by +1/10. If I plug in -1.001, I'm not going to get 0 in the denominator. I'm going to get a small number. So these are all valid. I just don't want to include -1. So not including it, I have a open parentheses. Okay, I can go all the way this direction. I can go start at -1 and go more negative, but I just cannot include. There's a hole here. There's a gap right there at -1. So in interval notation, we go left to right. So I'm going to start at -infinity. So open parentheses, -infinity. And all of these numbers are valid up to -1. And I use a parenthesis, because it cannot be equal to -1. That would be a bracket like we saw in the above problem. And then I have more. I have another region. So there's two regions. It's broken up right here at -1. So I can union this together with -1 all the way up to +infinity. So I put -1 up to +infinity. Again, if this is really new, if interval notation is really new, our textbook has more on this in section 1.6. So you can go back to that previous section and look at more examples, or you can look at the section that we're in, domain and range, and see some more examples. I highly recommend doing that. There's some great examples in our textbook about functions, domain, writing in interval notation. Okay, for our final example, h of x equals 3 of x plus 2, we found that the domain is all real numbers. So if we were to make a number line, and everything is valid, everything's valid, the whole number line is shaded. Well, that would be the interval negative infinity to positive infinity. So instead of writing out all real numbers, this is kind of shorthand for that everything works from negative infinity up to positive infinity. Okay, let's take a look at two more examples about finding the domain and then writing it in interval notation. So again, domain, if we're looking at domain, we assume that all real numbers work, and then we start to restrict things. And here I have a denominator, and so I know that a denominator cannot be equal to 0. So I take my denominator, I say this cannot be 0. When is this 0? So I solve this, this equation, but we just have a not equal to sign. So how do I solve that? Well, x squared minus 1 factors into x plus 1 times x minus 1. That cannot be 0. So I have this factored form. This means that neither of these factors can be 0. So x plus 1 cannot be 0, or x minus 1 cannot be 0. So that means x cannot be negative 1, or x cannot be positive 1. So that means we have two restrictions. There are two values that make g of x have a denominator of 0. And you can check this. So I'll put some check out to the side here. I'll erase this in a moment so we have some more space. So g of x, if I say g of negative 1, that would be negative 1 over negative 1 squared minus 1, which is negative 1 over negative 1 squared is positive 1 minus 1. And there you see we have a denominator of 0, which is undefined. Likewise, if I were to consider x equal to positive 1, if I were to evaluate g of positive 1, that would be positive 1 over positive 1 squared minus 1, which would be still 1 minus 1 in the denominator, and that would be 0, which would still be undefined. So either of those values make our domain undefined. So we want to write this in interval notation. Again, I would start with a number line. And here we have 0, positive 1, negative 1. And we said all real numbers are valid. Everything's valid except negative 1 and positive 1. So all of these are valid until you get to positive 1. Positive 1's not valid, and then we can go on. So you see that we have three different regions. So how do we write that in interval notation? So I start from the left side. We start at let's see if I can put a, I was going to try to cover up this you try, but if I start from the left side, we start at negative infinity. We are valid up to negative 1, but not including it, so we use a parentheses, union for our second interval, negative 1 up to positive 1, union positive 1 to infinity. So this is our domain in interval notation for that first problem. All right, I had to clear out some space there, make it a little bit more space for us to write. In the second example, h of x is equal to the square root of 2 minus x, and then plus 3 outside of the square root. Again, if we're trying to find the domain, we assume everything works, and then we start figuring out, okay, in this situation, this isn't going to work. Well, we have a square root. And we know that square roots are only valid in the real number system if you're evaluating the square root of things that are greater than or equal to 0. So it's not that x needs to be greater than or equal to 0. It's whatever is underneath the square root has to be greater than or equal to 0. That needs to be greater than or equal to 0. So I'm going to solve this equation and figure out what values of x make this 2 minus x bit greater than or equal to 0. So subtract 0 from both sides. And now I need to divide both sides by -1. Dividing both sides by -1 flips that inequality symbol. And now we have x is valid when it's less than or equal to 2. So let's just check that out to the side. Does that make sense? It's always good. Does it make sense? So let's say h is, well, what would be less than 2 that we would want to check? Well, 0 is easy to check often. So h of 0, square root of 2 minus 0 plus 3 outside of that. So we need to do what's inside the square root first. 2 minus 0, square root of 2 plus 3. Yeah, that works. I don't even need to evaluate that. I could with a calculator, but I can take the square root of 2. Let's try 3. Okay, we're going to make sure something, we're going to look and see what doesn't work. And it says that it has to be less than or equal to 2. So does 3 not work? So the square root of 2 minus 3 plus 3, that would be equal to the square root of -1 plus 3. And here is where we have a problem in the real number system. Square root of -1 is not a real number. So that means that 3 is not a valid input. So now that makes me a little more confident that that x less than or equal to 2 is our valid range. So let's draw a number line, kind of help us write an interval notation. Here's 0, 1, 2, and I want all of the numbers that are less than 2, so this direction, but we can be equal to 2, so that means there's a bracket here. So in interval notation, I start from left to right. Here we have on the left side -infinity, so parentheses -infinity up to 2, bracket, because it can be equal to 2. What happens when it's 2? We have 2 minus 2, which is 0. Square root of 0 is valid, is just 0 plus 3. So that works. So there's our interval for number 2. All right, let's talk about what should you try before moving on to the next video. So the directions for these problems are to find the domain, find and write the domain. Whoop, not writhe, write. Although maybe some of you might writhe doing some of this. Find and write the domain in interval notation. So question 1, f of x is equal to 1 over x minus 4. 2, g of x equal to x squared. And the third function to think about is h of x equal to the absolute value of x. Try those before moving on to the next video and bring those answers to class.